Today we're going to work with solving radical equations. So similar to the work that we used when we were solving equations in general, the big thing that we have to worry about is how are we going to get our x isolated? How do we get it by itself? And we've got some radicals that are involved with this. So if you see 2 times the cube root of the quantity x minus 3 equals 4, what's the first thing that we have to do to get our x isolated, to get it by itself? We're going to unwrap this. What are we going to do? And, all right. Viviana, what do you think? We want to get the 3 away, right? We're going to have to add 3 at some point. Very good. But it's currently under a radical. So we need to get, first of all, the radical isolated. And then we can start working with that. Divide by 2. So let's divide by 2 first. And when we do that, 2 over 2 is gone. It's a 1. We'll have the cube root of x minus 3 is equal to, and 4 divided by 2 is 2. So that looks better because now we at least have the radical isolated. Okay, so the very first step is going to be to isolate the radical. Get the square root, the cube root, the fourth root, whatever it is, all by itself first. And then we'll tackle getting rid of that radical. So this is a cube root. What's the inverse of a cube root? How do we get rid of a cube root? We cube it. So if we cube the left side, we also have to cube the right side. Okay. So the second step is going to be to raise the radical to its inverse power. Okay. So the nice thing about it is the cube root of something cubed is whatever was underneath that radical. And what is 2 cubed? 8. 2 times 2 times 2 is 8. Tristan, what's the next step here? Add 3, absolutely. So now x is going to be equal to 11. Now, one thing to be aware of, whenever we square something or we cube something or we take it to the 4th power, we have the possibility that we may have introduced extraneous roots. What word does extraneous have in it? Extra. We may have introduced extra roots by cubing it. So we always have to check our work to make sure that this answer does actually fit the solution. So when we put 11 back into the original equation, we would have 2 times the cube root of 11 minus 3. Is that equal to 4? So inside the radical, 11 minus 3 is how much? 9 or 8. 2 times the cube root of 8, is that going to be equal to 4? So first of all, the cube root of 8 is, and 2 times 2 is 4. It checks. So no extraneous roots were introduced this time. All right, so you've got an example just like that to the right of it that you're going to work for yourself. Okay, next one. Now we want to solve the cube root of 2x minus 5 equals, minus 2 is equal to 3. So what will be the first step of this one? Sydney, what's the first thing we're going to do here? Add 2, very good. The last time we had to divide 2, this time there's a negative 2 hanging out with it. So to isolate the radical, we have to get it by itself by first adding 2 to both sides. Okay. When we do that, what do we get, Drake? Good. At the left side is the same, and we just get 5 on the right side. Okay. What's the next step, Dawson? Good. We would cube both sides. Now we want to eliminate the radical by cubing both sides. So what do I get on the left side, Laurel? Yep, 2x minus 5. It just drops out. Cube root, cube, gone. 2x minus 5 on the left. And what will I get on the right, Brenna? $125. If you don't have that one memorized, you got to have your calculator out to quickly be able to pull that out information out. Okay. Alexis, what's the next step? Perfect. So 2x is now equal to 130. What's the last step, Jordan? Divide by 2. X is 65. Now, before we call this one good, we have to check for an extraneous solution. So when we do that, the cube root of 2 times 65 minus 5 minus 2, should that be equal to 3? Always do what's in our radical first and do your multiplication first. So what's 2 times 65? 130 minus 5. So we'll have the cube root of 125 minus 2. Will that be equal to 3? Yes, because the cube root of 125 is 5. 5 minus 2 is 3. So it checks. Okay, so you've got one just like it next. The 3 here or the 3 on the other end? Yep, the cube root. So we're asking ourselves, we don't necessarily ignore it. We do what's inside of it first. And then we say, okay, what is the cube root of 125? That would be 5. And then 5 minus 2 does equal 3. So we're good. Okay. But always do what's in the radical first. Everybody's good on that one? All right, next example looks like this. So our first step was always to isolate the radical. Is the radical all by itself? Okay, so what's the next step going to be? We'd like to get the x's to the same side, right? But we've got this radical that's a barrier, that's a blockade that won't let us do that. So how do we get rid of that radical? We have to square it because it's a square root this time. The other one was a cube root, right? So we cubed the cube root. We're going to square the square root. But if I square the left side of the equation, I have to square the whole right side of the equation. And Cheyenne is giving me a frowny face. Because she knows what this means, right? We don't get to just square the x and square the negative 4. We have to square the whole right side. So we square the left side. Let's do the easy part first. Caitlin, what are we going to get here? Yep, they cancel, so perfect. Okay. Now, x minus 4 quantity squared. That means we're going to take x minus 4 times x minus 4. Whether you want to FOIL it out or use your product boxes, both work. Or you might start to recognize a pattern whenever we square something. So what do we get when we square that, Ben? What else? Good. And then last one. Perfect. Okay, so it is basically squaring the first term, multiplying these two together and doubling them, because it's the same thing twice, and then squaring the last term. Okay. Now how do we solve for x? What do you think, Christian? Subtract 7 from both sides. You do know. Good job. And while we're at it, what else should we do? Back 7 over, might as well, yep, make the 2x come over too. Because we can only solve these things if it's a 0 on the one side. So there's lots of things that multiply to get 2x plus 7. But there's a very limited number of things that multiply to get 0. So we'll have an x squared minus a 10x, and 16 minus 7, bless you, 9. Positive 9, so plus 9. Remember all that time we spent factoring things? Using the quadratic formula, completing the square. We'll get to review that. So what's the next step? Three terms. What do we do when we have 3 terms? Try the greatest common factor. Do they have anything in common? Not this time, right? So always try GCF first. Okay. And now T-chart, right? Yeah, we're going to figure out our T-chart. So we want factors of 9 that add to get negative 10. So factors of 9 are 3 and 3, 9 and 1. Which ones will add up to get a negative 10? The 9 and the 1. Okay, so we'll do an x and an x, and then 9 and 1. And what do our signs need to be? Both negatives. So we get a positive 9 when we multiply them together. So close to being done. Now what do we have to do? Set them both equal to 0. X minus 9 equals 0, or x minus 1 equals 0. What makes the left side 0? Positive 9. What makes the right equation equal to 0? Positive 1. Now we check one more time to make sure we didn't introduce extraneous zeros. Okay, do you see why we don't give you a lot of problems with these? Because there's a check at the end. Okay, so we're going to plug these back in. When we try 9, we're going to take 2 times the 9 plus 7 under our square root. And is that equal to 9 minus 4? So I substituted 9 in everywhere I saw x in my original equation. So what is 9 plus 7? And 16 times 2? 32. Is the square root of 32 going to be equal to 9 minus 4? No, there's no way square root of 32 is ever going to be 5. So that's an extraneous solution. It came because we squared things. Okay? Let's try our other one. We want to try x equals 1. So we're going to take, oops, I messed up. Sorry, guys. This should be the 2 times the 9. Yes, thank you. 2 times the 9, and then plus 7. Shouldn't have changed. This wasn't, the x wasn't with the 7, it was with the 2. So 18 plus 7 is 25. And the square root of 25 is 5. So that one's good. Okay, it's also negative 5, but we're good here. Okay, now we're going to plug in our 1. The square root of 2 times 1 plus 7. Will that be equal to 1 minus 4? So the square root of 2 times 1 plus 7 reduces to 3, because we'll have a 2 plus 1 is, or 2 times 1 is 2, plus 7 is 9. The square root of 9 will be 3. Is that equal to 1 minus 4? That one's a no. Okay, so there's our extraneous solution. So x equals 9 is our only answer to this solution, or to this equation. Okay. So far, so good? Okay, so next example. What are we going to do with that one? What does the 1/2 power mean? Square root. So don't let them trip you up. Just because they threw a 1/2 power in there doesn't change the process, right? If you prefer to write that as a square root, you can. Or you can recognize that what do we have to do to make that 1/2 power go away? Square it. Okay? So if we square both sides, one half to the 2 becomes a 1, so we just get our x plus 12. And when we square x, we'll get x squared. What's the next step, Christian? It's like last time. What'd you do last time? Taking the 12 to this side, we probably want to have a positive x squared, right? So we've never really factored a negative x squared. So let's take the 12 to the right, and then at the same time, let's also take the x to the right. Are we cool with that? Okay. So we get a good old 0 on the left. So we always have to get the 0, get everybody to one side if it's quadratic in order to solve it. And we'll have an x squared minus x minus 12. So we've got a trinomial. What do we have to do with this to solve it? What do you think, Tristan? How are we going to solve a quadratic or a trinomial? T-chart? I knew what you were trying to say. So we're going to figure out what are factors of 12 that will add to get a negative 1. Okay? Things that multiply to get 12 and add or subtract to get negative 1. So what are some factors of 12? 3 and 4. 6 times 2 and 12 times 1, right? Which combination can add or subtract to get us a negative 1? 3 and 4. So 0 is equal to, we'll have an x and an x. We have a 3 and a 4. What do the signs need to be? Plus 3 minus 4 because we want the bigger one to be negative, so we get that negative 1. Okay? So what are our solutions potentially? Yep. Okay. Those are our possible zeros, our possible answers. But what's the thing we have to do? Yep, gotta go back and check it. So let's see, does original equation negative 3 plus 12 to the 1/2 power equal a negative 3? Negative 3 plus 12 is 9. 9 to the 1/2 is the square root of 9, right? What's the square root of 9? 3, right? Okay, plus or minus 3 usually we would say. But notice how when we think about that positive root, it doesn't make sense, does it? Okay, let's try the 4. 4 plus 12 to the 1/2 power is equal to 4. What is 4 plus 12? And what's 16 to the 1/2 power? Yep, the square root of 16 is 4. 4 does equal 4, so we have our solution. Okay. Last example. What about this one? I like that. Let's write it as something that we can recognize. This is the 4th root of 3x all to the 3rd power. Does that look like something more manageable or something we're at least familiar with? Okay. It has a minus 2 hanging out with it, and we've got a 25 on the other side. So what's the first step going to be, Viviana? If we cube it, remember we have to cube both sides. So this whole part would have to be cubed. Should be kind of messy, right? So before we cube it, what's the very first thing we have to do? Yep. Isolate that radical first, right? There's a negative 2 hanging out with it, so we're going to add 2 to both sides. That way we don't have to mess with trying to get rid of or trying to do all of this. So we'll have a 4th root of 3x to the 3rd power, and that's going to be equal to a 27. Okay. Now let's take that guy apart. It's got a 4th root and it's being cubed. So let's do one thing at a time. Cube root it. Okay, let's take the cube root of both sides, because we know the cube root of 27, right? That's going to get us a 3. And when I take a cube root of the 4th root of 3x to the 3rd power, what comes down here? The 4th root of 3x. Does everyone see why? Because this and this are going to cancel each other out. The cube root and the 3rd are gone, but we still have this 4th root of 3x to contend with. What's the next step? How do we get rid of a 4th root? To the 4th power. Take them both to the 4th power. Whatever we do to the left, we have to do to the right. What do I get on my left-hand side now? What do you think, Kayla? Fourth root to the 4th power is going to go away, right? What's left? 3x. Good. And 3 to the 4th. Anybody have it memorized? 81. Last step. Divide by 3. So we have 27. So let's think about that. Is that going to make a solution for us? The 4th root of 3 times 27 cubed minus 2, will that be equal to 25? So 3 times 27, 81. What's the 4th root of 81? 3. So we've got the 4th root of 81 cubed, 3 cubed, minus 2. 27 minus 2, does that get us 25? Absolutely. So it checks. Okay. So 5 short problems, but make sure you do your checks. Okay. The right side of the worksheet is for you. Got about 10 minutes.